Okay, so please sign your attendance. And Assalamualaikum and good morning. Good afternoon. And for today we're going to cover one question related to the CPU scheduling algorithm. And before that, I'm just going to go through the final exam information for the last time. And these are the structure of the question. So you're going to have 3 questions. Okay, all of the questions are subjective. And each of the question worth 20 marks. And in total, there are 60 marks. That will be equivalent to 40% out of your overall marks. And the topics that will be covered for your final exam are this. Okay, you have IPC model. So you have to know how to explain the message passing and also the shared memory. And you have to know on how to use the Amdahl's law and also the scale speed up formula or the Gustafson's law. And these are the formula that you have to memorize. Okay, you have to memorize because it won't be included in your final exam. Okay, it won't be supplied in the final exam. And for the CPU scheduling, it will be related to tutorial number 5. And you might be asked on round robin, SJF, or priority. Or it could be all of them. So you have to know each of the scheduling algorithm except for FCFS. Okay, you don't have to know. Okay, there won't be any question on FCFS because FCFS is quite easy. So I won't ask on that one. And the last one is on the computing paradigm. Okay, so for the computing paradigm question, you'll be given a scenario, and then you have to suggest a computing paradigm, and based on the scenario. So I can suggest is try to focus on these 3 computing paradigm. And then the reason why I suggest these 3 computing paradigm is because it can suit to most of the scenario. Okay, it can suit to most of the scenario. So the computing paradigm is really is on topic number 2, if I'm not mistaken. So please go through that slide, and then there will be it. Any other question that you guys want to ask related to the final exam? So this will be the last time, and I'm going to explain about the final exam. Anything else that you want to ask? Nope. Okay, so good. And like I mentioned just now, for today's session, we're going to do one exercise based on the CPU scheduling algorithm. So for the first 10 minutes, you guys are going to try to find out the answer, and then we'll discuss it. So for this one, okay, this is on CPU scheduling algorithm, and this is on round robin. Okay, so for this question, the quantum value is 2 units. So what I want you to do for the first task is I want you to try and draw the Gantt chart for this question. So if you look at here, there are 5 questions. Sorry, not 5 questions. There are 5 processes, and each of the processes have been given an arrival time and also a burst time. So I want you to draw the Gantt chart for this question, and the quantum value is 2 units. So the Gantt chart that you have to draw is the round robin. Okay, I'll give you about 5 minutes, and then we'll discuss. Thank you. Okay, so let us discuss the question. Don't worry if you got it wrong during the exercise. Okay, it's just an exercise, so don't panic. This is LT21SB. $5240. Okay, so this is the full Gantt chart. Sorry about my handwriting. It's bad. Never mind, I'll just draw it again. So P1, and then P2, 0, 2, 4, and then P3 is 1 unit, and then P1 is 2 unit. Okay, and then you have P4, another 2 unit, and then P5 is another 2 unit, and then P2 is another 2 unit. Sorry, not another 2, it's another 1. Okay, so you have only 1 left for the P2. Okay, hold on, let me finish off with this. Then you have P1. Hold on, where's my thing? So this one's supposed to be P2. Okay, so P2, P1, and 13. And then last one is P5. Okay, so this is the full Gantt chart. Okay, we have P1, P2, P3, P1, P4, P5, P2, P1, and P5. So how do we get that? Later on, I will share a software for you to check whether your Gantt chart is correct or not. So let me explain how do you get that. Okay, so let me draw the table again. Okay, so you have the process ID, okay, PID, and then you have P1, P2, P3, I'll just erase them, I'll just put it there. Okay, so P4 and P5. So you have AT and BT. So AT stands for time, BT stands for burst time. So the arrival time for P1, P2, P3, and P4 and P5 are as follow. So you have 5, 3, 1, 2, and 3. 5, 3, 1, and 2, and 3. Okay, so you have to look at the arrival time for each process. So you have to list down the clock. Okay, this is just one of the method for you to get the full Gantt chart. So at clock 0, the P1 arrive. Okay, as you can see here, this is the ready queue. So on the right hand side is the head, and on the left hand side is the tail. So when clock is 0, P1 arrives. So it will be in the queue for a few milliseconds, okay, or just a while, and then it will go on into the CPU execution. Okay, so at clock 0, the P1 arrive, and then it will go into the CPU execution. And at clock 1, as you can see here, at clock 1, the P2 arrives. However, the P2 will not be able to be in the CPU execution because the P1 is still executing. And if you look at the burst time of P1, it is 5, isn't it? Okay, it's 5. And then the quantum for the CPU execution is 2 units. So it has to wait until the P1 finish until 2 units. Okay, so the P2 will be on the queue list or on the ready queue. All right, and then at clock 2, the P3 arrives. Okay, at clock 2, the P3 arrives, and the P3 will be queuing behind of P2. Okay, the P3 will be queuing behind of P2, and then once the if you look at here, once the P1 finish, we still have a remaining of 3 units, isn't it? Because we have used 2 units, so we have remaining of 3 units. So that remaining will be at the back of the queue. So it will be placed after P3. Okay, it will be at the back of P1. So it will be at the back queue of P3. And then at clock 3, okay, the P4 arrives. So at clock 3, the P2 will be basically not at clock 3. At clock 2, the P2 will be inserted into the CPU execution. And then when at clock 3, the P4 arrives. However, the P3 can't proceed with it can't go into the CPU execution because at the moment the P2 is still processing. Okay, at clock 3, the P2 is still processing, and then at clock 4, the P5 arrives. Okay, the P5 arrives. So at clock 4, the queue will be P3, P3, P1, P4, and P5. And at clock 4, okay, the P2 has finished with the process. Okay, and if you look at here, I missed out the P2. Where should I put? Okay, the P2 should be here. Okay, the P2 should be here. Okay, so the P2 should be here. All right. Sorry, not P2. P2 should not be there. P2 should be. Sorry. P5. Yes. Okay. So P5. Okay. So it will finish off with P3. Okay. So if you look at the P3, what is the burst time of P3? The burst time of P3 is 1. Okay. So the P3 will be in the CPU execution for 1 unit, and then you will have P1, P4, P5, and P2. Okay, all right. And then on the next stage, okay, the P1 will be going into the CPU execution, and what's left with P1? If you look at the P1, is only left with 1 unit. So it will be going into the CPU execution for 1 unit, and then you're only left with P2, P5, and P4 in the ready queue. Sorry, it should not be read like that. It should be P4, P5, and P2 in the ready queue. And then at clock 7, okay, it will execute. Okay, it will finish off with the execution of P1 because the P1 had, okay, we have 2 units. Okay, so there you go, P1, and then the P1 finish. And once this execution is finished, you still have 1 unit left. Okay, you still have 1 unit left. So that 1 unit will be at the last queue. Okay, it will be at the last queue in the ready queue. Okay, it will be after P2, and then you have P4 going into the execution. So for P4, you have 2 units. Okay, so it will use all the quantum units in the CPU execution. So there you go, at clock 8 and clock 9, okay, it will finish at clock 9. So the P4 CPU execution will finish at clock 9. And then at clock 10, the P5 will go into the CPU execution, and then it will go until clock 11, because for P5, okay, so what's the unit for P5? Sorry, not unit. What is the burst time for P5? The burst time for P5 is 3. So the first 2 units will go in during the clock 9 and also clock 10. All right? And then what happened next is it will proceed with the next P2. So the next P2 will go into the CPU execution, and then what's left with P2? You're only left with 1, I guess. Okay? And that 1 unit will be going into the CPU execution. Sorry, not that one. This is supposed to be this one, okay? And then it will finish off with that at clock 12. And then P5, sorry, not P5, P1 is going into the CPU execution, and it will use 1 unit of the quantum time, okay, because you only have 1 unit left. And then the P5 will be going into the CPU execution for 2 units of the quantum time, and then that's it. Okay, so that is how you get the Gantt chart. So in order to get the correct Gantt chart, you have to do it step by step. Okay, you have to do it step by step, then only you can see the process. Okay, and from this Gantt chart, can you try to calculate the waiting time and also the turnaround time? So the formula to calculate these 2 times are finishing minus with the arrival, the turnaround time minus with the burst time. So can you do that for me? Please calculate the turnaround time for each process based on this Gantt chart, and please calculate the turnaround time for, sorry, not the turnaround time, the waiting time for each process based on this Gantt chart. So this is the Gantt chart. Okay, this is the Gantt chart. Okay, I know that most of you were asking why P1 comes, I'm sure that most of you were asking why P1 comes after P3, right? Why P1 comes after P3. So if you look at here, okay, let me explain these first 4 lines. So at clock 0, the P1 arrives. Okay, as you can see, the arrival time of P1 is 0. So at clock 0, the P1 arrives, and then it will straight away goes into the CPU execution for 2 units. Okay, for 2 units. And then at clock 1, the P2 arrives. But the P2 will not be able to go into the CPU execution because the P1 is in the process, okay, it's in the CPU execution, and it has to wait until the P1 finished, because the CPU execution time for P1 is 2 units. And then at clock 2, okay, the P3 arrives. So the P3 will be in the next queue after P2, and then at clock 2, the P1 finish with the CPU execution, and it still have remaining of 3 units, because the total burst time for P1 is 5 units. So it still have another 3 more units. So that 3 units will be preemptive to the last or to the back of the queue, which is back of P3. Right? Which is back of P3. And then at clock 2, okay, the P2 is going into the CPU execution with a unit of, what is the unit? Okay, with a unit of 2. Okay, with a unit of, 2 units. 2 units or 1? 2 units. And then at clock 3, if you look at here, the P4 arrives. So the P4, the P4 will be placed at the back of the queue, which is behind of P1. So that's how these 4 lines works. Okay, that's how these 4 lines works. So I hope that you understand why. Okay, I hope that you understand now why the P1 comes after P3, not P4. All right. So I will give another question for you to do it during your free time. And what will be the turnaround time for P1? Anyone? The TA of P1? Sorry? I can't hear you. 13. 1, 3, yeah? Okay. And then P2? 11, P3? 3, okay, P4? Okay. And then P5? 10. Is it 10? Okay. And then the waiting time? P1? So 13 minus with the burst is, what is the burst? 5. So 13 minus 5 is 8. And then P2, 11 minus 3 is 8. And then P3, 3 minus 1 is 2. And then P4, 6 minus 2 is 4. And P5, 10 minus 3 is 7. Okay, so that's the waiting time for each process together with the turnaround time. So you have to calculate the average for the turnaround time and the average for the waiting time. So you just add up all these processes time and you divide with 5. You divide with 5. Then you will get the answer for the average waiting time, for the turnaround time, and the average waiting time for the average waiting time. Yeah, the average waiting time. Okay, so that is how you do the question. Okay, and let me share with you another question for you guys to do it during your free time. And before you leave, I just want to share with you one software that might be useful for you guys to draw the Gantt chart. Where is that thing? No, not that. Come on, where is that thing? Show all bookmarks. Okay, there you go. All right. This is the next question for you guys to do it during your free time. Okay, let me disconnect this and go to my thing. So 5184. Okay, so that is the question for you to do it during your free time. And if you look at that, there are 6 processes, and you have been given an arrival time and also a burst time. So first thing first, you have to draw the Gantt chart, and then you have to calculate the average turnaround time and also average waiting time for this question. All right, so that will be your exercise for this week. And for the software, I think I have shared with some of you. Hold on, yeah. Nope. Is it that one? Okay, that one. All right, so I'm going to share in the main WhatsApp group. Bear with me. Okay, so I've shared the link for the Gantt chart software. Okay, you can use the software to generate the Gantt chart for this question, but you have to know how to get the Gantt chart. All right, so that will be your practice for this week. And if you don't have any question, I guess that will be it for today. And for the last class next week, we will cover another question on the CPU scheduling algorithm and also the Amdahl's law. All right, so if you don't have any question, you're free to go. And thank you for attending this session. And for those who have not signed in their attendance, okay, please sign in the attendance before you leave. And I'll see you guys next week. Thank you.